The TARDIS is a lie told in the right direction. A police box smaller on the outside than the inside, space folded against its own grammar, the container humbled by what it contains. I watched Doctor Who for years, through Tennant, through Smith's frenetic energy, into Capaldi's quieter and more philosophical tenure, and what kept drawing me back wasn't the monsters or the melodrama. It was the physics backdrop, the way temporal mechanics were treated with a seriousness that rewarded sustained attention, the lore threading that reached back past the 2005 relaunch into decades of accumulated canon. I haven't watched since Capaldi left, but the TARDIS stayed, not as a narrative device, not as nostalgia, but as a geometric intuition, a shape. A question about what containment actually means once you stop assuming space behaves the way three dimensions taught you to expect it to. The central hypersphere paradox has been lodged in my thinking ever since I first encountered it, because it gives you the TARDIS running backwards, not a container smaller than what it holds, but something built inside a container, by the rules of that container, that grows until it exceeds the container's walls. The inside becoming bigger than the outside, not through narrative magic but through the cold arithmetic of high-dimensional geometry. The setup is clean. Take a hypercube, the n-dimensional generalization of a cube, with side length 2 extending 1 unit from the origin in every direction along every axis. Into each of its 2 to the nth power corners, pack a hypersphere of radius 1/2, each one tangent to the walls and to its neighbors. In the space remaining at the center, place a single central hypersphere, tangent to all the corner hyperspheres. The question is simply, how large is it? The answer is a function of dimension alone. The distance from the hypercube's center to the center of any corner hypersphere is the Euclidean distance across n dimensions, each corner coordinate sitting at plus or minus 1/2, which gives the fraction with numerator the square root of n and denominator 2. Subtract the corner hypersphere's radius of 1/2 and you have the central hypersphere's radius. R sub c equals the fraction with numerator the square root of n minus 1 and denominator 2. A clean formula, no hidden variables. The paradox is already inside it. At n equals 2, the central circle has radius the fraction with numerator the square root of 2 minus 1 and denominator 2 almost equals 0.207, smaller than the corner circles. The geometry behaves. At n equals 4, the central hypersphere has radius exactly 1/2, the same as the corner hyperspheres. Symmetrical, composed, still sensible. At n equals 9, the radius is exactly 1. The hypercube extends 1 unit from its center in every direction. The central hypersphere now touches the walls. At n equals 10, the radius is the fraction with numerator the square root of 10 minus 1, and denominator 2 almost equals 1.08. The wall is at 1. The central hypersphere, which you constructed inside the hypercube, which you placed there by the same rules that govern everything else in the structure, now protrudes beyond the walls. It exceeds the container. Not because of an error, not because the construction breaks down. The 1024 corner hyperspheres at n equals 10 remain perfectly inside. The central hypersphere is still tangent to all of them exactly as specified. But because this is what high-dimensional space actually does. The rules were followed precisely and the container stopped containing. This is the central hypersphere paradox, and it belongs to a broader class of results that mathematicians group under the curse of dimensionality, a name that captures their shared character well. These are not pathological edge cases. They are the normal behavior of high-dimensional space, which simply does not resemble the space we inhabit and have built every intuition inside. The curse is that our intuitions are not wrong, exactly. They are accurate for the dimensions we can see, and catastrophically misleading everywhere else. The deeper result in this class of problems is the one about volume. The volume of an n-dimensional hypersphere of radius r is v sub n of r equals the fraction with numerator pi raised to the n divided by 2 power and denominator normal gamma times open paren n over 2 plus 1 closed paren times r to the nth power. For a unit hypersphere, this volume rises with dimension initially, peaking near n equals 5, and then collapses back towards 0 as n right arrow infinity. The hypercube's volume, 2 to the nth power, grows without bound. the fraction of the hypercube occupied by a hypersphere inscribed within it, which starts at roughly 78.5% in 2 dimensions and 74% in 3, falls continuously and approaches 0. In high enough dimensions, the inscribed hypersphere occupies essentially none of the hypercube's volume. The container is almost entirely empty of the largest thing that fits inside it. The volume retreats into the corners. This is the geometric fact underneath the curse. In high-dimensional space, corners proliferate exponentially, 2 to the nth power of them, and they pull away from the center. Almost all the volume of a high-dimensional hypercube lives at maximum distance from the origin. In the regions where equidistance from the center, the defining property of a hypersphere, simply cannot reach. The hypersphere and the hypercube are structurally opposed as dimension increases. The container organizes its mass precisely where the contained cannot follow, which is the TARDIS inverted. The TARDIS takes a small exterior and folds a vast interior inside it. The contained exceeds the container by authorial decree. The central hypersphere paradox takes a container that appears to hold everything, built by legitimate rules, and demonstrates that the thing inside it grows through the walls by mathematical necessity. The inside becomes bigger than the outside without anyone deciding it should. Dimension decides it. Follow the formula far enough, and the central hypersphere, politely constructed in the exact center of a legitimate hypercube, extends quietly through walls that are no longer walls in any sense that three-dimensional vocabulary can name. I find this worth sitting with for reasons that go beyond the geometry itself. A significant portion of what breaks in complex systems, in models with many interacting variables, in high-dimensional data, in any domain where the number of parameters grows large, breaks for exactly this reason. The intuitions that were reliable at low dimension stop working. The space between things grows vast in ways that don't feel like growth from the inside. The container stops containing. Most of what you thought was full turns out to be corners, and the corners are unreachable. The curse of dimensionality is not a theorem about abstract mathematics that has no bearing on anything else. It is a description of what happens to every framework built on low-dimensional intuition when it encounters a world with more axes than it was designed to handle, which is to say most of the genuinely hard problems. The TARDIS, then, was not just a narrative convenience. It was the show accidentally pointing at something true. That the relationship between inside and outside, between container and contained, between what a space looks like and what it actually holds, does not stay fixed as the geometry changes. Dimension is not neutral backdrop. It is an active variable, and it has opinions about what fits where. And its opinions become stranger and more violent the further you follow them from the three axes where human intuition was trained.